Hello and welcome to the project presentation of the Advanced Microcontroller Laboratory 2020. Today's date is 3rd of August and the time is 1:26 p.m. CEST. So my topic for the project is the option number 3, sensor dashboard, and we shall go over the questions one by one at first. Okay, so the first question asks us to implement a library for the ultrasonic sensors that's on board. First of all, it asks us to write a library for the same and also to calibrate the different parameters of the sensor based on the values that we receive. So on the left hand side of the screen you can see the library, the implementation of the library of the ultrasonic sensor. Basically we have used 40 kilohertz as the center frequency of the sensor because that is mentioned in the data sheet here on the right. Here we see the 40 kilohertz as the center frequency of our sensor. So the basic working principle is that a burst of 8 acoustic pulses are sent of 40 kilohertz each, and the reflected pulses are received. So two pins are used for the purpose, one to send the pulses, which is through pulse width modulation, and one to receive the pulses, which is basically done by polling. So two timers have been used for this purpose. Timer 0 has been used for generating the pulse width modulation frequency of 40 kilohertz, and timer 1 has been used to keep a track of the time. We measure the time in microseconds to maintain the accuracy of the whole measurement process. After that, we can use the distance formula as we see here to get the distance by using the time of flight by 2, because of course there is one pulse for time for going and coming back. Also, to keep debouncing into to introduce debouncing into the whole equation, we send 5 of those groups of pulses and then take an average out of those 5 measurements to get a good value. Secondly, let's move on to the second question. In the second question, the project asks us to measure the distance of the ultrasonic sensor that we just saw, and then to measure the acceleration from the MMA IC that we used in exercise number 3. It asks us to measure the XYZ position of the joystick by using the ADC IC on the controller board 2. Then it asks us to measure the light intensity, the potentiometer status, the temperature by using the internal ADC of the MSP430. And it also asks us to measure the status of the push buttons on the controller board 1. One important point to mention here is that due to the unavailability of pins, we could not measure the push button status of all the push buttons. We instead measured the push button status of PB1, 2, 3 and 4 because they are routed through the shift register, but we could not measure the status of PB5 and PB6 because they require one pin each for their measurements. So we shall take a look at the different pins and how they are being used, and this will clarify the whole point further. So as we see on the screen right now, here is a pinout of our MSP430 microcontroller, and we see what each pin has been used for. As we see, all the available pins that were mapped out of the controller have been used for some purpose or the other, and to keep the code complexity to minimum, we could not implement them as a multiplex pin. Basically, we kept one purpose to one pin. So after implementing everything, we had only 3 pins left for use. So we interface them to the 3 LEDs, which we will need for the fourth question. So we instead measured only PB1 to PB4 and used the remaining 3 pins for our 3 LEDs, red, green and blue respectively. A copy of this document will also be placed on the project folder for reference. Going back to the project questions, one important feature to mention here about the first question is that the range of the ultrasonic sensor was limited to around 20 centimeter, and the accuracy is a little less, so it gives proper distance for a large object, which is hard in consistency. But if we place a softer object, suppose like a sponge or a rubber, it fails to detect it very accurately. So the range comes down to around 10 centimeter for softer objects. Moving on, for the third question, the project asks us to output our sensor values that we just measured in the question number 2 to the serial terminal, but also not print the whole table every 2 seconds, but just the change in sensor values by using the VT100 sequences. So this has been implemented in the project, and this has been done by extension of the UART library that was already provided to us by using some functions as shown on the left. So this can be accessed in the project folder later. So basically what we do here is we send the escape sequences, and a capable program can understand them, such as PuTTY. There are very few programs which are capable of understanding VT100 sequences, so we have used PuTTY as one of them, as mentioned in the project question. The last and the final question of our project requires us to put our MCU in receive serial mode and receive commands, simple commands like LED blue on, or LCD print something, some string, or LCD clear, or relay on or off, as we will see them. Now let's look at the implementation of the whole project. So on the bottom right corner, as we can see, there is a board which is running a copy of our code. So here on the right we have the controller board 1, which has the microcontroller, and on the left we have the controller board 2, which has all the sensors and the LCD. So we already have an instance of PuTTY running a version of our code, but we shall load a fresh version and see how it behaves. So the code is loading. Right, the code has loaded. As you can see, the self test for the MMA accelerometer is going on, and the self test was successful. So we proceed further. As we can see, at first the sensor dashboard with empty values was loaded, and it was subsequently filled up with the sensor values. So as you can see, first of all we have the distance. So if we don't detect any object, we say 0 centimeter as the distance. And then we have the accelerometer values here, we have the joystick values here, we have the LDR value followed by the potentiometer and the temperature ADC values. We have not converted them for simplicity. So basically this is a 10-bit ADC value which will go up to 1024. And at last we have the 4 push buttons. So after that, after printing it, it waits for a serial command briefly. If it gets it on the serial interface, it executes the corresponding command. So as you can see, the board is standing upright. That's why the y-axis values in the minus y-axis gives us the acceleration due to gravity value of minus 9.8. So now what we shall do is we'll lay the board out flat like this, and we shall see the z-axis value would change. Yes, as you can see, the z-axis now gives us 9.8 because that is the positive direction of the z-axis as given in the sensor data sheet. So now what we shall do is we shall test our ultrasonic sensor by placing our hand on top of the ultrasonic sensor. As you can see, it is giving us some values. So if you go a little further, it shall give us the distance values. Yeah, so that's working. And now let's look at the joystick values. So let's move the joystick Y position to the extremity, and as you can see, since it refreshes at a slower position, slower rate than the rate of change, that's why we don't see instantaneous change in the sensor values. And similarly for the x-axis, it does the same, and also for the z-axis. So the basic value when the joystick is at the middle is 255 by 2, which is 127. So that is approximately 127. Then coming next to the LDR value, if we place our finger on top of the LDR should give a lesser value. As you can see, it drops suddenly. Then what we shall do is we shall check the potentiometer ADC values. Let's increase it, and it shall give us the highest value possible, that is 123. And if we go down on the other way, it should give us a 0. Yes, that's what it does. And for the temperature value, we can switch on the heater, but I have a simpler way to demonstrate it. So now we have a value of 366, and I'll place my finger on top of the NTC sensor, and it shall rise. As you can see, it has risen from 366 to around 390, and now it has dropped again. Yeah, exactly. Right, so that then we can see that the NTC is also working. Now let's go for the push buttons. If we press push button 4, it gives a 1. Then we push button 3, it should give a 1. 2 gives a 1 and 1. We can also test to our collective presses of the buttons, like 1 and 4. Then we do for 2 and 3. Yeah, just like that. So the buttons pollings are also working. Next, what we want to test is for the last question, how to send serial commands to the board. So for that, we will not be using PuTTY because it's very hard to send commands from PuTTY. So basically what we will do is we'll use H-term for sending the commands, but in H-term we won't see a very formatted version of our sensor dashboard. It will be because H-term does not support VT100 sequences, so it will be all over the place. So we'll switch off PuTTY here. So as we can see on the top right corner of the screen, we have an instance of the H-term software running, and we see garbage on the serial receive side because it does not support a VT100 sequences like PuTTY does. We are using H-term because from PuTTY we cannot easily send serial commands, so H-term is mainly used to send the serial commands to our board. So first of all, as you can see, there is already some text appearing in the LCD over here, so we shall try to clear that using our function. Let's say LCD clear, and you can see the text has gone away from the LCD here. And then let's see if we can print something to the LCD. Let's say LCD print, and we say hello, or yeah, and you see hello has appeared on the LCD. So this is working. Next, we shall try to light up one of our LEDs on the board. Let's say the green LED, and we say LED green on, and you can see the green LED has switched on the controller board 1 here. And next we shall try to switch it off using a similar command, which is LED green off, and it switches off here. So that is also working. Next, the only remaining command is for the relay. We say relay on, and you see the relay has switched on here. The only way you can see the relay switching on is the yellow color LED. So a point to mention here is that we are using pin number 2.6 to interface the relay here, and that's the same pin which is connected to the serial input pin of the shift register connected to the shift LEDs here. So when we switch on the relay, the shift LEDs also go on all at a time. So we had to do it because we did not have many pin options, empty pin options, as mentioned in the video before. And we shall try to switch off the relay now using a similar command, which is relay off, and we can see the relay and also the LEDs have gone off. So as a whole, the whole project is working, and if you have any further questions, please do not hesitate to contact me. Thank you and have a good day ahead.